Hello, everyone. Good afternoon to you all.
Thank you, sir. Uh, Let me introduce first. So, my name is Ram, and I'm co-founder and CTO of ByteFirst Private Limited here in India, Hyderabad. We are located in Hyderabad. Uh, so, thanks for the opportunity, sir. So, I'll start this presentation. Um, so let's talk about the artificial intelligence. So it's like a very buzzword these days. So everyone is talking about artificial intelligence a lot. So what exactly it is? So well, as the name suggests, artificial intelligence, commonly known as AI, is a way of artificially making a computer intelligent. So what is making a computer intelligent? Right? So making a computer intelligent is nothing bad. So it has to think like a human being. It has to do the task like a human. So that is called artificial intelligence. So according to the father of the artificial intelligence, John McCarthy, so it is the science and engineering of making intelligent machines, especially intelligent computer programs. So these intelligent computer programs will do the task by their own, taking the decisions by understanding from the data. So that's what actually the artificial intelligence is. So the intuition and motivation behind the AI. So the motivation and intuition behind the AI is like a human brain, nothing much, just a human brain. So as a human brain, if you see something like that, if you are seeing an orange fruit for 10 times or 20 times, you will easily understandable, right? So you can in the next time, if I show you the orange fruit, you will tell that it's an orange, even if you don't know in the previous thing, because you understand that thing. In the similar way, the algorithm will also learn the patterns, and it predict. So our brain is like wired in such a way that, so neocortical memory, so there is a layer in our brain that's called neocortical memory, is responsible for storing, not the images, actually not the images, not the sounds. It is responsible to store the patterns of the data. Like if you see some car, it stores the pattern, not the image of the car, right? So in the similar way, the algorithm will also understands the pattern of the data, and whenever a new data point comes, no, then it will understand the pattern, and it will tell us what it exactly. So that is the intuition and motivation behind this AI. So why we need these intelligent machines, right? So we are able to do everything, but why we need these intelligent machines? So the one primary reason behind this AI is to automate the tasks that people feel are redundant. So we know that there will be redundant tasks in every day. So we want to automate them using that intelligent machines. And the thing is like, the computers are much faster than humans in terms of calculations. If you take an example of multiplication of two to three numbers, digit numbers, it is too bit difficult for us humans. So few of them are super brains, they can do that, but many of them are can't. But machines will do very easily, right? So this is one of the reason. Sorry, yeah, that's it. And yeah, so till now we have discussed, means we talk about the artificial intelligence, all these things, right? So then what is the machine learning? The machine learning is also one of the word. So what is the machine learning? So machine learning is a way to implement the artificial intelligence. So artificial intelligence is a concept, and machine learning is the way to implement the artificial intelligence. So machine learning is a branch of computer science in which you devise or study the design of algorithms that can learn. So how will the computer learn automatically? So this is the big questions to many of us. How will the computer learn automatically? Yes. So it will learn the things from the data, right? So you feed in the data having different attributes or features that algorithms have to understand and give you the decision based on the data, right? So once the algorithm has learned and interpreted the data, right, it means it trained the data, it trained the algorithm trained on the data, and it gives us the model. So you can test it with any of the new data, so then it can predict. So in a simple example, if you take an example of finding the price of the house, so there will be consider like if few houses will have 3 rooms, few have 4, few have 6, few have 10, right? Here the feature is considered like a rooms. So if the number of rooms are increasing, the price will automatically increase, right? And the where the house is located. So these are the features like the location of the house and the number of rooms of the house, the square feet of the it, and other features of the particular things. So all will give some inputs to predict the value of that particular house. So in the similar way, we will provide all the data like number of rooms, where it is located, how many square feet, and everything will give it to the algorithm. The algorithm will learn from that thing, and it will predict the house price of that. So in the next time, if you want to know about the house price of a particular place, you just need to give the input, then the square feet of the house and how many rooms is there in that, and what are the other features you have in that. You just need to give that thing. The algorithm will give us the price of that particular house. This is how the computers will learn. So if you further dive into the means machine learning, the machine learning is broadly divided into three. Like one is like supervised learning, unsupervised learning, and reinforcement learning. So these are the we broadly classified the machine learning into three. So we'll go into one by one. So what is supervised learning? So the supervised learning, as name suggests, it learns from the data, where in the data is already has the label. Label is nothing but what need to be detected. If you take an example of apples and oranges, so we will give the data in such a way that apple has a color, it has some stem, it is in the shape, everything will give it, and will tell that this is an apple. In the similar way, for orange also, we'll give all the details of the orange color, everything, and we'll give the label as orange. So another example is like the best example is like cat and dog. Consider like a cat and dog. So cat has different features, right? And dog has different features. We'll provide all the features to the data along with the label. Now we train the algorithm on this data. So here in supervised learning, we are giving both data and the ground truth. Ground truth is nothing but the label of that, like cat, dog, orange, and apple. So it will train on the data, and it can predict what it should be. Like you have given 100 cat data and 100 dog data, and you trained the model, and next you have given another animal data, right? So it will check with all the data, and from that model, it will predict us whether it is a cat or dog or orange or apple, like that. This is called supervised learning. And coming to the unsupervised learning, so it is bit different than that. So in the supervised learning, we have provided the label also, like it is a cat, it is a dog, it is an apple, it is an orange. So we have given the label too. But in the unsupervised learning, we won't give the data, means it this data don't know what it is actually. So we have given a data. So the algorithm has to learn by itself, and it will form the clusters based on the patterns of the data. So that is called unsupervised learning. It don't know what data we have given. That algorithm itself learns the clusters in that, and it will give us the data, give us the output. So for this example, we'll take the same examples, okay? So orange, apples, cat, and dog. So I have given all the data without telling that it is a dog or cat, or is it orange or apple. So once I gave the data to the algorithm, it will cluster the data points based on the patterns present in the data. So all oranges will have the some pattern that are like same color, shape, and weight and everything, right? In the similar way, or apple will also have same. So that's how it clusters the data. Here, if you see, consider it is like a dog, it is like a cat, it's an orange, it's an apple. So that's how it clusters the data. So here I have been cat, dog, horse, and monkey, but you can imagine that. Then the third thing is like reinforcement learning. So it is bit different than both of them. So it is actually like it'll learn like a uh, reward based. So the basic example of thing is like, if you take an example of small kid, okay. So you can show him the fire, and if you say it will, if you touch that it will burn, no, right? So he may not understand. So once he go near to that heat, once he touch that, he'll get that burn. So it will learn, it's like a reward or fine. So he won't do the same task again, right? So once you get the best rewards, like if you kept some obstacles in his way, and is slowly um, bypassing those things and moving forward, then he learned that whenever an obstacle comes, you need to take a turn, right? So this is called reward based learning. If you do a step and you learn something, right, it's like a trial and error kind of learning. This is, we call it as reinforcement learning. Generally this particular reinforcement learning, we'll use it in the gaming part of it. So games, whatever the video games you are playing, so they will use this kind of algorithms. Let's come to the deep learning. So that is about the machine learning. We broadly classified into machine learning. There are many algorithms in each of the model, like in clustering, like KNN, K-means clustering. There are many algorithms are present. I just broadly divide into them and I explain that. So coming to the deep learning. So what is the deep learning, right? So the deep learning is inspired by the artificial neural networks, and these artificial neural networks, commonly known as ANN, were inspired by the biological neural networks of the human, right? Yeah. So in deep learning, algorithm is able to learn hidden patterns from the data by itself. So as discussed earlier, in machine learning, you need to tell that it is an apple, you need to tell the size, color, stem, all these things, weight, right? So in this, we don't need to tell all those things. In deep learning, the algorithm itself will understand the hidden patterns of the data, and it will give us the decision whether it is an apple or a something else. Okay, we need to give the labels that it will only understand. We don't need to give that this is the shape, this is the weight. We don't need to give that. It can understand by itself, and it is inspired by the human biological neural networks. I'll explain in the next slides. So why deep learning? So machine learning is there, right? So why do we need the deep learning again? So deep learning, so in these social media time, so we have lot of data is available for us. If you take an example of Facebook, we are generating lot of data, right? Likes, shares, sharing the images, emotions, and lot of things, right? So we are giving lot of data to the big companies. So they need to process all the data, right? So for them, if you have more data, you need to, your models will be more accurate. To process them, that you need to have more high performance computing also needed. Nowadays we have large amount of data, and we have availability of high performance computing. So we have both of them. That's why we are using the deep learning. So deep learning is already present. uh, it has been around for decades, but last 15 years or something, we are able to access high performance computing and everything. So that's why it is more popular now. If I'm going bit fast, please tell me.
Yeah,
Hello.
Ram, please slow down a little bit. Actually, yes, you are going a little faster.
Yeah.
Yeah.
So,
Okay. Go ahead, please.
so I need to move it down, please. Okay. So as I said, deep learning learns features and tasks directly from the data, and we don't need to tell anything to the algorithm. We need to build the algorithm. The algorithm will automatically understand from that. So the data can be images, text, and sounds. So deep learning, actually we are using more in image classification and natural language process. So image class, if you take an example of image classification, face recognition is one thing, and identifying the objects, and image segmentation, scene understanding. These all are come under image processing. And coming to the natural drawing processing, and converting language, one language to another language, and speech to text, and these all will come under natural language processing. So for this thing, we are using deep learning. So what is deep learning now? So I said, right, it will learn the hidden patterns. So what does that? So we'll take an example of Apple again. So a deep learning model first identifies the low level features like edges of an apple. Then it slowly understands the more complex features like body and stem. Finally, it combines all the learnings and shapes, colors, and other characteristics of that particular apple to identify the apple. So this is what will happen in the deep learning. So what it does generally in the deep learning, what it does is like first it will understand the low level features, edges, and all those things, and it will go to the next level of the features like body, stem, and all those things, and color, and it will combine all of them, and it will tell us whether it is an apple or it is an orange, right? So the understanding part is like a mystery box too for us now, right? So we are giving an apple image. The deep learning neural network is understanding what it is, and it is telling us it is an apple. That is deep learning. So as I discussed, what is the difference between machine learning and deep learning, right? So in a traditional machine learning approach, we need to provide the features to the model, to the algorithm. Like if you want to predict if you want to predict the price of the house, we need to provide the number of rooms, where it is located, and uh, s- like square meters or square feet of the particular home, and everything we need to provide to the algorithm. The algorithm will process and will give us the output. But in case of deep learning, we just need to give the data. Whatever the data we have, we need to format it, and we need to give it the data. That from the data, it will understand, the algorithm will understand by itself, and it will give us the data. So that is the difference. Here we are actually reducing a lot of manual effort, and some kind of domain expertise also we are reducing in deep learning. Yeah, this is the pictorial representation of that. In a machine learning, to find a car, to identify a car, okay, so some domain expertise should be there. He has to code all the features and give it to the model. This is nothing but a algorithm, and it will identify whether it is a car or not. In case of deep learning, we are actually eliminating this step. We are directly giving input to this algorithm, and algorithm is identifying the features, and it is telling us whether it is a car or not a car. So from last few slides, I'm talking about neural network and everything, right? So how exactly it happens is like, if you take an example of car, I give the car and the label is a car. So then I gave it to the algorithm. This is learning, like first it is understanding the edges of this, like the tire edges, light edges, and all these windows and everything. It is understanding it, and it is going to the next level of that. And then it is finding that it is a car or truck or bicycle or something else. So it is just understanding in this such way. This we will call it as the black box right now. The process of understanding the features and everything is called black box now. This is nothing but our neural network. Yeah, I'll explain what is neural network now. So already we discussed, right, how the neural network came. It's inspired from the human nervous system. So if you take, it is an input layer, it's an hidden layer, and it's like an out layer. So we are giving data to some neurons. Consider like it is a neuron. Okay, so first I'll explain the human brain. So whenever we see some image, okay, our neurons will take the input from the input medium like ears or eyes or touch something, right? So it will take the input from that, and it will pass it to the next layer. These are called another set of neurons, and it will pass it to the another set of neurons, and it will give us the output. So it will send a signal to the brain that what it is exactly, right? In the similar way, we are also building one artificial neural network, where we are giving an input to the neurons. Consider these are the neurons here, okay, and this neuron is processing something, and it is giving output to the some other neuron. It is further processing something, and it is giving to the some other neuron as an output, right? So this exactly is looking like a human brain. Here these are called neurons. Here we'll call these as perceptron. So in the human system, it is called neuron. In this artificial neural networks, we'll call these as perceptrons. So if anyone has any doubts in between, please ask. Yeah. So as I said, in our nervous system, neurons are the thing. In the neural network, artificial neural network, perceptron will be there. Yes. So before talking about the perceptron, what it does and everything, I'll explain based on the data. So as discussed right previously, there is a house price. In the similar way, we have something like this. Some data, cell size, cell shape, some kind of disease related data it is, and what kind of disease it is. This is nothing but our predicted values are need to be predicted, ground truth values. Okay. So we'll call all these columns as features, and this is called output. So we'll generally name all the features using X, and the output are a label using Y. So these are X1 to X10 are the features of a particular row, and this is nothing but our output. Okay. So what actually is the perceptor? Now we'll discuss. So like a single unit in neural network, right? In a artificial neural network also, there is a basic unit that is called perceptron. As I said earlier, we are giving input to the one neuron, and it is processing something, giving the output, right? What it actually processing, it is adding some weights to it and multiplying, and it is giving the output. So if we take an example of y equals to mx plus c, where y is our predicted value, m is nothing but our weights, and x is nothing but our features. So here we are doing some mathematical operation, and we are producing the output. This is called the complete step is called the perceptron. That is a single layer perceptron. Now we are discussing about the multi-layer perceptron. So when a perceptron that teams up with additional perceptrons stacked in several layers to solve a complex problem. So to solve a complex problem, one particular, sorry, sorry. So to solve a complex problems like identifying the car, identifying the sheep, identifying the human face, one perceptron may not be sufficient, because we have many features. We need more perceptrons to calculate that thing, right? So we'll use more perceptrons like this, 1 2 3 like this, and we'll have hidden layers. Hidden layer is nothing but a layer in between the input and the output, is nothing but the hidden layer. We'll have multiple hidden layers. So if you have more hidden layers, the network is more complex. To solve the more complex problems, we need to use the more hidden layers. Okay. So here we'll discuss about the hidden layers. So hidden layer is nothing but the layers in between the input and output layer is called the hidden layers. Most of these we'll call it as a black box. As discussed, in the input we have given as an apple, and the output is telling us the apple. So in between this is called black box. So all the hidden layers will call it as black box. And in this hidden layer, what will happen is like we'll apply mathematical transformations of the data. So here we are applying something, right? So it will give the output to the this layer. Here we'll do some mathematical transformations of that particular data, and will output it to the another layer. So the output of the first layer will give the input to the next layer. That's how it will pass through the all the layers, and it will predict what it is. These are called multi-layer perceptron, and these are called hidden layers. The complete structure will call it as neural network, a convolutional neural network or artificial neural network. So what exactly happening with a face recognition example? Okay. So here we have taken three hidden layers. Hidden layer 1, 2, and 3. There is an input layer, there is an output layer. Okay. So we have given faces to the input layer, and in the hidden layer, as discussed, how deep learning works. Deep learning will first understand the edges of the object and go to the next level of the objects, and it will understand the shapes, and then it will predict, right? In the similar way, I have given plenty of faces to this input layer. In the hidden layer, first hidden layer, it is understanding the edges of the places like this edge, and this edge. It is understanding the edges here. In the next hidden layer, it is understanding the eye, nose, chin, cheeks, all these things it is understanding here. And in the third layer, it is understanding more complex features like understanding the face. Okay, understanding the face. And in the output layer, it is telling that who exactly it is, right? Here I have given one name is Peter, one name is David, one name is something, right? So it will understand that and it will predict it here. Hope it is clear. Yeah. So this is the you can consider it like a blueprint of a convolutional network. So where we'll give the input to the input layer here, and it will take to the convolution neural network first layer. Here in convolution neural network, we have many things like activation functions, max pooling layers. So I'll brief it out. What is activation? Activation is a function which converts the input using some mathematical transformations and produce the output. That is called activation layer. And activation layer is important. Without activation layer, even if you had 100 layers of 100 hidden layers also, there won't be anything to learn. Only these activation functions will give us learning. And polling means we want to understand the edges of the face, right? So we need to apply the polling, max polling, average polling. So we want to learn the features from the input layer. For that we'll use the polling. So we'll use the different combination of activation functions, polling layers, and convolution neural networks will form a complete convolution neural network which can understand the input and produce the output. Yeah. So for deep learning, we have many frameworks are available, but most popular of from the deep learning is like TensorFlow and PyTorch. TensorFlow is backed by Google, and most of the researchers and students will use the TensorFlow. It is very famous, um, and it supports all the NLP, image classifications, and it will supports all kind of machine learning and deep learning. And PyTorch is one of the beautiful framework available. It's a open source. Both are open source. Yeah. So these are the frameworks available in the DL. There are many others. These are the most famous. So from here, the presentation of the theoretical explanation is completed, and we'll jump into the practical building of model, predicting the things that we'll see it in the next thing. So till now, if you have any questions, please.
Yeah, we
Hello.
can go ahead, Ram. At the end of the session, we can have the question and answers.
Sure. So to train this algorithm, I'm using TensorFlow, and this is called Google Colab. So if you don't have a machine, means a GPU machine, for learning purpose and building the GPU things, and you can use Google Colab. Okay, I'm using the Google Colab for this thing, and this is from the TensorFlow itself. This example. So what is this example is like, we have flowers, iris flowers. Okay, so it has three variants of flowers. Now we are going to detect the flower, what flower it is. Okay, so here the dependent libraries I'm loading it, and runtime we can choose here. So it has these runtimes: TPU, GPU, and none. None means CPU, it will run on CPU. GPU means it will run on GPU and TPU. So I just use the TPU. Yeah. So we are loading Matplotlib. Matplotlib is nothing but to plot the data. It will use it for our visualization. And this is the TensorFlow library, which helps us uh, model, building the model and defining the architecture and everything.
Do you want to say a little bit more about this TensorFlow library, or is there any documentation which you want to share?
Yeah, I'll share it at the end of this session. Actually, TensorFlow is the library which helps us to build the deep neural networks with an ease. So it has the Keras background. Keras is one of the framework. It helps us to build these layers, whatever we discussed, right? There is a hidden layer, there is a neurons, there will be like perceptrons and activation functions, applying the max pooling layers and converting them into output. So all these functionalities built in TensorFlow, we just need to know that what need to be done on that particular thing. If you want to add one more layer, it's just a task. You just need to write one line of the code, right? So once you added that code, it will add the layers. You don't need to write everything in Python. Generally we use Python for this particular thing. We don't need to write the entire code for that. You just need to import the TensorFlow, and I'll provide you the documentation for the TensorFlow at the end of this session. And this will help us more into, like, it will convert our data into tensor. So why it is TensorFlow? Okay, so generally if we take any data, there is a data type, right? Int, float and everything. This TensorFlow will use the data as tensor. Tensor is nothing but a multi-dimensional array matrix. Tensor is nothing but a multi-dimensional matrix, and this will call it as tensor. So whatever you want to train, first it will convert the data into tensor, and then it will apply the algorithm on top of it. So this is the brief about the TensorFlow. um, so I just imported it here. So I'll explain about this particular problem which you're going to solve right now. So these are the flowers now we are going to detect. By giving the data, it should identify what kind of flower it is. Iris. So here in our data we have three kinds of flowers. That is nothing but Iris setosa, Iris virginica, Iris versicolor. These are the three things we have, and here you can see that you can understand the size of the flower, petal and sepal. You can understand, right? So the petals are big here, here which is like small. So here the color is bit different, and the petal and sepal length is completely some difference is there, right? So this is how the flowers are separated it out. So how we will learn? By seeing this flower, this is like Iris setosa. So we understand the pattern of this flower, right? The width and length of the flower. By seeing that, we understand this. In the similar way, in our algorithm also, it will understand the pattern of the flower, and it will tell us the output. So here I'm here trying dataset URL, right? So this dataset is available in the online in the TensorFlow org itself. So we are downloading it from there only. Yes. So it has a local copy. I already run this thing. Now I will show you the first five data set of the means. This is the data set we just downloaded. It's a CSV format. We just downloaded data set. I'll show you the first five data points. Okay, here you can see 6.4, 2.8, 5.6, 2.2, and this 21120 is right. So these are nothing but the flower type. 0 is nothing but setosa, and 1 is nothing but virginica, and 2 is nothing but this versicolor. So the first five are like this. So this is like, here you can see sepal length, sepal width, petal length, and petal width. These are the features, and these are the labels as discussed in the previous presentation. So this 6.4, 2.8, 5.6, 2.2, all are X. These are the features for us. And this 2 is the right. This is, we are going to predict it. This is nothing but our Y. Y is nothing but our ground truth. Okay. So here we are giving those column names for that thing. So as discussed, as I told you, right, the first column is like sepal length and sepal width, and the second two columns is like petal length and petal width. Species is nothing but our flower type, like setosa, those things. And this particular line, what is doing is like it is separating it out from the data, like last one except the last one, all will come into feature names, and the last one is like our label name. So as I said here, the first four, right, are features. The last one is like our label. So here we are using Python language. So by using the Python language, we separated the features and the labels here. Yeah. As I said, iris setosa is 0. So we are naming, means we are labeling it as like, so these algorithms won't understand this textual data. We need to convert into numerical data or float data, right? So we have converted it like iris setosa is 0, iris versicle is 1, and iris virginica is 2. That's how we have named it. And these are our original class names. We're creating one list here. So here actually we are building the data set. Here we are actually building the data set. As I said, we need to build the data set in, it should be understandable to the TensorFlow. Here if you see, this is the function it is helping us, make CSV data set. And we are using here label name. We know the label name and column names. The column names already we defined in the above. The batch size means how many of them in each epoch, and training data set FP. The training data set FP is this one. From that we have converted into data frame, right? This one. This is nothing but data frame for us. Yeah, now we can see that. So we have created a training data set, right? This is a train data set. From this train data set, we just see that how the labels and features are there. I'll add one more thing here. So here what it does is like sepal length. All the flower sepal length is created like a dictionary here. And all the sepal width is like a dictionary. All the petal length is like a dictionary. Means all it actually by the column name it separated the data, which is ready for the training. And we'll see the labels also. So these are our labels. As I said, tensor, right? So these are our labels. 2, 0, 1, 1. So we'll plot a small means we have used the matplotlib, right? We'll plot a small uh, visualization to know how the data is actually separated. So if you see, this is one kind of flower, this is another kind of flower, this is another kind of flower. So we have given petal length in the x direction, x thing, and in y we have given the sepal length. So the data is separated like that. So if you remember in our clustering algorithms, I said right unsupervised learning also. Generally we do it like this only. All the data which is similar to this will come into one cluster. This is another cluster. This is third cluster. Means the data is properly separated, right? Because this is a testing data. In the real time, it won't be like that. It will be like very clumsy. But this is a very, it's like for the learning purpose. That's why the data is very clearly separated. And if you want, you can change these things like sepal length and petal length, right? So you can use width also here. You can see that. Sorry, I gave the wrong. Yeah, here you can see. This is how it's separated. You can change this also. So we have changed our column names also accordingly. So this is how the data is separated. So now we need to convert our features into vectors. Okay, so to understand, to make it understandable to the algorithm, we need to convert the data into vectors. This is the function which will convert the data into vectors. You can see it here. So what it is like, it is using the stack functions to convert the data into this thing. And here you can see how our data is converted. So this is how the data is converted in a tensor format. So here, to identify something, we'll have the multiple models to use it. So we have several models to use it, but we will use our own model. And as we discussed, we need to build a neural network, right, to identify something. Maybe it is the iris setosa or versic or something. So that I'll explain it here. If you take in the earlier presentation, I told you, right, we are using inputs into input layer, and we are passing it to the hidden layer. In the hidden layer, we are making some mathematical transformations, and we are passing it to the output layer, where we are detecting what kind of element it is, right? So this is what it is. In the input layer, we have input features like sepal length, sepal width, petal length, and petal width, length and width. This we are giving it to the each perceptron here, and it is giving it to the, it is connected to the another perceptron of the hidden layer. This we will call it as fully connected layer. So there is no disconnection in any of the thing, right? So we'll call it as a fully connected layer, this one. So here we are creating the original model. This is the model created. So we have a sequential functionality in Keras. Keras is framework which helps us to create the this model, this neural network. So we are using Keras. Keras is inbuilt in TensorFlow. We don't need to download it again or configure. It will come automatically with the TensorFlow. So sequential is the approach. So layer dense, we are using 10 perceptrons, and we are using activation function as relu. As I said, activation function is very important, and input shape is 4 because our number of features in our data is like 4. Here we say, right, sepal length, sepal width, petal length, and petal width. That's why we took input shape as 4. And this is the dense layer. Dense layer is nothing but this is the hidden layer. The first one is the input layer, the second one is the hidden layer, and the third one is the output layer. Here we have used the 3. Why 3? Our number of classes is 3, that's why we have used 3. So as I said, activation function, right? Here you can see the activation function determines the output shape of each node in the layer. These non-linearities are important. Without them, the model would be equivalent to the single layer. Without an activation function, even if you have multiple hidden layers also, it is equal to the single layer only. So if you have an activation function, it converts the input into the output in a different way. So there we have a lot of, there are many, we have activation functions, relu, leaky relu, softmax. There are many, many functions we have, but generally in the hidden layers, we'll use the relu. And you can ask question here, how many hidden layers I can have? You can have as many hidden layers you can. It depends on your problem. It depends on your identification, the object features. If you have more complex features, you need to build more complex architecture. So here we are building a small, a simple neural network architecture here. So we have built this model. So we finally will build this model. Okay. And I haven't trained the model here. I just built the model only. Okay. So I would like to predict using my model. I haven't trained the model, don't know anything about my data. I'm just giving the input, expecting the output. Let's see what will happen. So I have given the features, all my features, and it predicted like this. We'll see what it actually predicted. And we are using softmax function to get the actual output. What softmax function will do is like it will calculate the percentage of this thing, and it will give us the output. Generally we'll use the softmax at the hidden layer, not at the sorry, at the output layer, not in the hidden layer generally. So if you see here, these are my original labels. Without training, it predicted all are one, right? So it hasn't learned anything. We just build the model and we gave the features. We asked us to get the output. So it gave all these things. So this is like wrong prediction, right? Most of them are wrong predictions. Very few are actually predicted correct. So now we'll train the model. So we know that without training, without learning, it is giving us wrong predictions. Now we need to train it. So for the training, so in the training we need to calculate the loss of the each epoch. Epoch is nothing but one iteration. Okay. So in each epoch, we need to find the loss. Why do we need to find the loss? If you know the loss, you can correct the weights using a gradient descent. We can correct the weights. By correcting it weights in step by step, we can improve the accuracy of the model. We can improve the performance of the model. So to that, we need to find the loss in each and every iteration. So here we are using sparse categorical cross entropy function to calculate the loss. So this is also available in TensorFlow itself. We don't need to write anything. We just need to know what exactly it does. That is enough. So I'm taking that function to calculate my loss. And here I'm defining a functions to calculate the loss. So I'm using the same loss object, y true and y predicted. Y true means the ground truth. What is the exact label of this particular data and what we predicted. So we use this loss object to find the difference of this thing. Means how much accurate the model. We are getting the loss from this particular loss object. For that inputs are original value and the predicted value. So it will give us the loss. So if you see here, it gave us loss like 1.63, and we'll see next. So we are actually here calculating the gradient. I said, right? So we need to adjust the weights from iteration to iteration to make the model more perfect and more accurate. So for that, we need to calculate the gradients of the weights. So if you take an example, now the weight is 1, my prediction is completely wrong, right? How much it is wrong? We know that from the last function. So we'll reduce that and we'll add it again to the model and it will calculate. Now the loss has reduced, right? And then, okay, I found that. Then I adjusted some gradient and again I gave it back to the model. Then it passed through the all the layers and it will give us something else. So that is much more less than that previous loss. That's how we'll gradually increase the performance or accuracy of the particular model. For that, we'll use the gradient descent. We need to calculate the gradients of this particular weights. For that, we have written this function. We are finding the loss and we are using the loss value to calculate the gradient. So it's so this gradient we'll call it as an optimizer actually. So what optimizer does is like it will tell the algorithm to follow which direction it has to go. We have many like AdaGuard, RMS prop, there is a stochastic gradation and mini batch stoch SGD. There are many optimizer functions are available. We are using here like a stochastic gradient descent that we are using it here. So if you see here, there are different algorithms here and it has different parameters. Learning rate will be there and momentum will be there. There are many parameters available for this optimizer. Okay, so you can consider this is the our lowest loss value, right? To come here, it will check like this one, then it finally finds the slope and converts into loss. It got the lowest loss. So each algorithm will calculate in a different mode. If you give the momentum more, sometimes it will reach the lowest loss. Sometimes it may go into the different direction. So it is like a big concept. It itself needs at least 2 hours of time to explain that gradients, calculating the gradients and moment of this particular. So as I said, we are using the stochastic gradient descent, and I also spoke about learning rate, right? How much learning rate in each epoch that needs to be there, right? This you can change it. So I'll share this link with all of you, and you can change these values and you can play with them. So I took that optimizer. So for the same thing, we are calculating in step one is like 1 point. We applied the gradients and loss has reduced, right? Here you can see. So we applied that gradient and loss has reduced to 1.63 to 1.47 because we adjusted the weight in the second iteration. That's why the loss has reduced. So now actually we are now training the data. So this is the training. I told you like epoch. Epoch means iteration. I'll keep only 100 here. So number of epochs is 100, and where x is nothing but our input features, and y is the predicted. This is the truth value that need to be predicted by using this thing. And gradient we are using the stochastic gradient descent (SGD), and last value is like cross entropy. We are using it, and we are calculating the accuracy here. I'm just running this. It may take some time. So here you can see the first iteration loss is like 30%. Sorry, accuracy is 30%, and loss is like 1.2 in the epoch, and in another epoch the loss is like 0.365, accuracy is 92.5. So if I increase this 100 to, means I'm increasing the number of iterations, 300. Let's see what will happen. 97 to 98, but it memorized the previous steps. It is not doing it from the start. It memorized this step 97%. From that it again started. Now if you see, the loss is getting down 0.9, 99.167. It is almost like 100%, right? Because the data is in such a way, is a training data, you get this 99.167 with a minimal code. But in real time data it will be completely different. You need to do a lot of um, hyperparameter tuning. There will be much more steps to find that particular thing. And here we see how this loss training and test training loss, how it by epoch we'll see it here using the this matplotlib. We'll visualize that how it happened. Loss has slowly reduced to this. In the similar way, accuracy is very low and it jump into like this and down, down, down. Finally, it sets here, 99 point something, right? So this is the best accuracy we got. At 300 epoch. So here, this is how you can see. It's because in machine learning and deep learning, these visualizations will give us some more ideas. If you know that, then only you can while in hyperparameter tuning, you should use these visualizations to know whether this particular tuning is working or not. So this helps a lot. So now we will test our model. So I just downloaded the data. So this is also available in TensorFlow itself. I just downloaded the test data of same particular iris flowers. Okay, it's taking some time. And the similar way we have converted this data into this one. Turn on it. Interrupt execution. Yeah, I got it everything. Now the test accuracy is like 96%. So if you remember, while we're training the data, we actually check the training accuracy. The training accuracy is like around 99 point something, right? but in the test accuracy it got down 96.67 because we have used the same data to test it. And on what data it has lent, we have given the same data. Consider like one kind of apples only I trained on it. I give the same apple to you and you are able to identify that, right? So I gave a different means in the testing what will happen now, it is like unseen data to the model. It's an unseen data to the model. So if I gave a different kind of apple, it should be understand. It should be able to understand it and give us the output. If it is able to give the right thing, then we can consider that the model is generalized. If it is unable to give the better output in the testing, then we'll call it as overfitting. Overfitting means it actually not lent anything. Sorry for the disturbance. Yeah. So if it is not giving the best output, like 99 to 96 is still okay. If our testing accuracy is like training accuracy is like 99, and when we use them the testing accuracy it came down to 50 or something, the model is overfit. It is not lent anything from that thing. It is just memorizes. It's by hearted the features. That's it. That we will call it as a overfitting. So to eliminate that kind of overfitting, there are other things like generalizing the data, normalizing the data. There will be other techniques will be there. These all will come under the hyperparameter tuning. So this will be many more steps will be there. So here we got 96.6, right? So we can consider that it lent very perfectly. 99 to 96 is like a yellow yellowed way of thing. Yeah. So I have given these three. For this particular first example, iris setosa 98% confident. For the second exam, second input, versicolor 96% confident, and this one 94.4% confident. So it will give us the confidence score. How much it is confident? The algorithm is the model is how confident it is to tell that it is that related to some kind of thing. I'll change something like here 4.5 and let's try test it. Iris set was only. So if I change it to 7.5 Setosa, 4.5. See, so this is a deciding factor. If it is less, it will come under Setosa. Maybe the petal length, I think. Petal width. If it is 1.5, I'm just playing with the data. I think writing this. So based on these things, it is telling iris setosa. If it is more like 7.5, I gave Virginica. So this is how you can play with this model. So we are giving the features like sepal length, sepal width, petal length, and petal width, and it is giving us the what kind of flower it is. Virginica or versicles, something like that it is giving. So this is how the deep learning works. Here, if you see, as I discussed in the while we are discussing about the deep learning, I told you that we don't need to give the features manually. We just gave the data, right? We haven't said that this is this thing we need to take like this. We just gave the data, it learns by themselves, right? So that's how the deep learning works. Generally deep learnings, and we are building an application called safe vision. So in the safe vision, what we do is like we identify the people behavior and their safety ppe usage. If someone, it's a simple example, like if you take a big manufacturing plant where someone enters without a helmet or without a shoe or without a proper safety ppe kit. So these days corona is also coming, right? If someone enters into any premises without a mask, then you need to identify them and warn them that you should not enter into it. So to do that manually, it is like very tedious. You need to have a three shifts. Two people need to be there at the gate. Everyone has to check, and you need to enter into the hall, right? But if you use this system like Safe Vision, what it does is like it will use the deep learning algorithms. We have built algorithm like this in a similar way, and it identifies that whether that face has the mask or not. If that is there, then it will allow. Otherwise, it won't allow. I will show you that too. small demo. Yeah, this simple example I'm just showing it to you. So if you see here, it is able to understand whether people has the mask or not, right? So if someone entered without a mask, it can detect that, and he has the mask. So it is also using the deep learning. So this particular lady don't have the mask, so it is telling us. So once it caught that, it will send an alert to the mobile, and it also shows here itself. And we have the complete dashboard system where you can see what is happening, means how many people are actually violated this particular thing. Everything we built around this particular deep learning algorithms. This is how it should be. So this is our office premises in Hyderabad. So this is like if someone without a helmet entering into our manufacturing plant, so it will tell us that. So if you see, there are people without a helmet, they are actually there, and this button without a no vest and no hand glove, he's roaming in the plant, consider like that. It caught violation is there. He violated the conditions, then it caught, and you can see the output here. So this is how it show the depot. Means how many who actually violated takes the picture and it will send us no helmet and everything. Actually, we used IBM Power System to build these kind of things. So IBM helped us in a great manner actually. So they have provided us the IBM technology to build these kind of neural networks and all those things. Thank you. If you have any doubts or something, please feel free to ask.
Yeah, Ram, thank you for the detailed and wonderful presentation, and sharing your insights. And also, like, you talked about PyTorch, right? Do you want to
Yes.
say a few words about PyTorch? How this
Yeah.
can be?
Yeah. PyTorch also similarly like a TensorFlow only. So people are using a lot in PyTorch also people are using very lot. Then it also works exactly like TensorFlow only, but it has some easy features to few people. Many people are more attracted to TensorFlow because it is backed by Google and they're giving the Google collab and everything. So many people are attracted towards the TensorFlow, but PyTorch also is giving us the best results.
Uh,
And we use the PyTorch only actually. So
yeah, the reason is actually, we want, the team wanted, how this TensorFlow library can be used as part of, developing a deep learning application. Like, what are all the APIs and how this could be used and all. Maybe one session, they may need. And then the other session is actually similar to uh, TensorFlow, PyTorch also, the team wanted.
sure,
I already have some requests from some people.
sure.
So probably, like, in our next session,
Yeah,
you can
we can have.
go ahead and present that. And this is very useful. Right now there are, like, I think 60 participants joined, and now 51 are still there. And also we have panelists, who are from Dubai and KLE and MIT and MIT Tamil Nadu and other locations too. Uh, I'd like to request Rashid Sayed to say a few words about why he's here, and what is that he wants, so that we can have a connect here. Please, Rashid, please go ahead.
Yeah, hi. Thank you, Ganeshan. So I just want to tell you that we are seeing AI in action. Now, for example, recently we have deployed AI to monitor our roads. We are monitoring our roads violation using artificial intelligence. So anybody, like anyone who's doing any kind of violation, for example, not wearing seat belt, talking on the phone, and changing lane without giving signals, all this thing now we are monitoring through AI now. And there are many other initiatives. We are working with government organization. Unfortunately, at this time I'm not able to share due to NDA with them, non-disclosure agreement. But in near future, once we at the right stage, I will share all this information. What are the other projects we are doing for the governments and authorities? So what I want to tell you, hopefully next year, early next year, I will be able to share you more details about this project. But right now, what I want to tell you that AI is in action. A lot of things are now deployed in production. So we are coming out of research and really it's being deployed now. So there are a lot of use cases, especially with government entity and and even in financial sector. We are seeing a lot of use cases. I would like to share some information in coming maybe early next year. So this is what I wanted to tell you, that AI is in
And all,
production.
and also, please say a few words about your company and where are you from? Because
Yeah.
the audience should know about it and opportunities you have coming, coming years, coming months.
Yes. So I'm based out of Dubai and in the Middle East, Dubai, and oh, and yes. So we have started working from last 2 years, but now we are seeing everything being deployed, coming to the stage where we are talking about production. So now AI is moving to production. There are a lot of things to discuss, but I need some more time. I think early next year I'll be able to give more information. This is because of non-disclosure agreement with the authorities here.
Sure.
So yeah, but
Uh,
yeah, thank you, Ganeshan, for organizing this session. Very useful session for a lot of people here. So I will be coming back after some time next year, early next year, to discuss a lot of other things, stuff about
sure.
AI.
Yeah. Thank you. Thank you. There are a lot of people like, showing interest and, want to do development on, the AI with our Power 9 system, as you know, and, and
Yeah,
definitely, there are system resources available, for people to work on that too. And, this is a kind of, the forum and a platform where the knowledge, I mean, now see Ram Babu, mentioned about he also used Power 9 and also Google Colab, to develop applications. Similarly, there are multiple people like, who have been doing that. And, we have another professor by name Satyadan Chekur, who is from KLE, he presented, 4 days back in this forum about his experience on on deep learning and the Power 9 system. Which is Chakur, you want to say a few words here?
Yeah, so hi everyone. So it's nice to see another session on power systems and trying to see, as Rashid said, now everything is going on in production in the field of AI. When we have come down out of the labs, right, to really implement and start using them. So most probably post COVID, you will see a lot of things which are AI based, which people would have done in the labs in this time, and it would surely be into production. So yeah, so this one area which is coming up, and it's a hot area for implementation, because now at least people are aware of how it can be implemented, and there are no tools available, systems available which support all this. The whole ecosystem and the whole software stack is available. It's not like 5 years back when people were just trying to do and set up the whole stack. Now it's all available, and it's really good for companies to really utilize those and come up with no products which would be really helpful. Yeah, so I have been working in this area now since 5 to 7 years now, from machine learning, the initial days of machine learning, to deep learning now. And we have also done some research oriented projects and some projects which I have consulted. Yeah. So, yeah, this is a good area to work on. And thanks, Ganeshan, for again giving me opportunity to attend the lectures, and specifically this lecture from, yeah.
yeah. And
Anyways,
Oh,
thank
I,
you.
I'd like to also thank you to IBM for making such a beautiful machine.
Yes.
This NVIDIA GPU machine AC922, it is amazing, amazing performance we get for training the model, and it makes it possible. Like now, it's possible to work and make quick changes in the model and come out with the production. So really thank you for IBM and NVIDIA put together a beautiful machine like called AC922, IC922. These are superb machine, you know.
Yeah,
So
sure. In this time, I just want to tell you that if you want to get access to this AC92, IC92, we can provide based on the project and based on the idea you have, so that you can experiment your solution on IBM Power 9 platform, and that's a great opportunity for you to learn and put it in your profile and probably sell your solutions if you are running a company, or sell your resume if you are working for a company, or if you are a student. So there are plenty of opportunities around the world with these skills. Anyway, thanks Rashid, and thanks Chikur for wonderful words about the Power 9 and the AI, your AI experience. And any other questions from audience? You can raise your hand, or you can post your question on the chat window or a Q&A window. Okay, I think Kishore Konak Konarkanti has a question. I think let me allow him to talk. Kishore, please go ahead. Kishore.
Hello.
Yeah, Kishore, go ahead, please.
Yeah. So hi Ganesh. Good evening and good evening to everyone. So I just wanted to know if there is a way to do some things in the IBM Power where we can have an access. So like the collab thing, right? So we can run a good number of computations on the Google servers. So is there any possibility that we can get access to IBM Power systems so that we can measure our products performance in the IBM Power as well? Is there any way for that?
Yes, Kishore. Send me a note, with a request. I just
Sure,
want to
sure,
know
sure.
which organization you are from.
Yeah, we are from Sigmalytics. So we are based out of Hyderabad.
Okay.
So yeah, so
Yeah.
I'll send you a note about that. And
Okay.
yeah,
Thanks. Yeah, sure. Please do send us a note, and definitely, we will be able to provide you access.
sure,
Thank
sure.
you.
Thank you, Ganesh.
Thank you. And any other questions, audience? Siraj Sayed, you have a question? Okay, probably I will allow him to talk. Actually, only a few questions, maybe. Yeah, Siraj. Siraj, you have to unmute. For
Yeah, what I'm saying is a great presentation, Ganeshan. Within a short period of time, we have able to understand the neural networks and all other presentations. What Ram Babu has explained in very short. So overall, I'm very thankful for all your guys. What you have given the basic presentation about the artificial intelligence and machine learning, and also the deep learning, neural networks, and all everything.
yeah, so this kind of presentations, will keep continuing, with the various speakers and professionals and highly skilled resources worldwide. And
Yeah, sir.
suddenly, the knowledge is wisdom here, and knowledge with the resources. I'm talking about that physical system, will map very well, and and will produce a very good results. And hopefully I can make that to available to multiple people in the world. Sure,
Oh,
Siraj.
that's a
Thank you.
great
Yeah,
job what you are doing, and also we'll share with our team members every time. But as you suggest, we will share the links and all. So prior to that, we should be ready for that presentation.
sure. Thank you, Siraj. Thank you
You're
very
welcome.
much.
Welcome, guys.
Any other questions, team? Okay, I think interest of timing, and we already passed 1 hour, and again I would like to thank Ram Babu for a wonderful presentation, and also the panelists and attendees who have been staying during the Saturday your time, and it's all looks like a technical feast. People are getting it from Open Power Foundation and academia and research team. Once again, thank you all for participating in this webinar, and see you soon in our next webinar shortly. Thank you. Thank you very much, team. Thank you.
Yeah. Thanks,
Thank you, guys. Thank you.
Thanks,
Thank you.
Ram.
Thank you so much.
Thanks, everyone.